you so much. Okay, good morning, everyone. My name is Oyeleke, Construction Management HND Level 4. I'm going to be presenting Unit 14, which is BIM Concept, Development, and Applications. A bit of background. My role is the role of a junior architect at the company called BIM Consultants and Engineering LLC. My objective is to help our organization to be able to adopt BIM in our design, construction, and management of assets. I'll be introducing the concept of BIM to the management team. I'll be highlighting the benefits, and I'll be outlining the steps on how to integrate BIM into the organization. The organization is based in United Arab Emirates. The references I'll be making will be from the United Kingdom because they have adopted BIM and they have made it with BIM. Some background information. BIM is an holistic process to manage the design, construction, and the operation of built assets. It is not just a software or a set of tools. It is not just modeling. It is a process that incorporates tools as well as management technique in the design and construction and operation of built assets. One of the specific advantages is the visualization that BIM offers, as compared to traditional method where until the structure is built, you have no idea what the structure might look like. As I explained earlier, it's a full cycle. BIM is a full cycle process, starting from the construction, the design, the operation and maintenance, the analysis, the detailed design. This is the beginning. Programming, when you identify what are the things you want to achieve a specific concepts, then design, then you can analyze, simulate, evaluate the impact these assets, how these assets will interact with the environment, how the environment will interact. Then you do documentation, fabrication of for things about then you go to construction. Then after construction, BIM can help to manage the assets, and after the lifespan of the assets, you can demolish or you can renovate, and the cycle goes back. So with BIM, you are able to have information from the beginning as to how all of this is going to happen. Some of the key terms in BIM is the BIM level. Right now, we're at level 2. Most people are at level 2. Most countries are in level 2 of adoption, which is the full collaboration level. The next stage is level 3, where there will be international collaboration and there will be standardization across board, when everybody will be able to exchange data internationally and there will be international standards. Another key term is the level of detail or the level of development, which can be defined as LOD 100, Some countries use LOD1 or LOD2. In some countries, they use LOD 100, LOD 200. This is talking about the level of details from conception to the built model. The level of details at conception is generic. By the time you get to fabrication, the details are more, and you are able to have an idea of geometry and the way the environment can interact with the building. You can do light simulation, you can do internal comfort simulation, you can simulate earthquake, wind load, and the rest. Another key term that is important to mention is the industry foundation format or the industry foundation specification. This template specifies that every file that everybody is collaborating with is in a format that is not specific to any proprietary software. For example, an organization is working with a particular licensed software, they will be able to exchange information without losing integrity by using this IFC format to share data, which is also similar to the BIM collaboration format. The view definition talks about the specific elements in the BIM structure. Then we talk about common data environment. Common data environment means what is the platform for sharing data? What is the protocol? Who is giving what information? Who is requesting for that information? At what point is this information? Who is generating that information? Who is the model author? And where is this data stored? So that's what common data environment talks about. The unit class classification system is used typically in UK, is to streamline the models so that everybody understands that if an element, for example, wall, is defined as a wall, then across board, everybody understands that this element is a wall because it has the unit class classification system. Another thing that is important to mention is the BIM execution planning procedure. With the BIM execution planning procedure, the BIM manager is able to define the protocol, what is expected to be achieved through BIM on a particular project. The model authors are defined. First, you define the project theme and the value. Then you define the project execution process. You define the exchange point for information, at what point you give information, and at what point you receive information. Then you define the infrastructure that is going to, support BIM. For example, you define, is your BIM going to be supported on a cloud system? Is your BIM going to be supported on an on-site system? Is your BIM going to use specific softwares? This is what the infrastructures talk about. Another thing that is important to mention is the life cycle analysis and the process map. The process map, like I explained earlier, is going to give us from the beginning, define the information exchange point. Who is collaborating with who? What information is who giving to who? So that's what the process map gives. Then the life cycle analysis. The life cycle analysis starts from the design and planning into construction and operation and maintenance. Unlike the traditional method, where the set of documents and information at this stage is different from the set of documents and information available at construction stage, and is also different from the information at the operation and maintenance stage. But with BIM, there's a common data environment where information about the building information from beginning up until the end of the life cycle. For example, the person that is operating and maintaining the facility has information about the manufacturers, the OEM detail, and the MS details, because BIM is able to generate immediately after construction the as-built model. Some of the benefits of BIM is that everybody that is working on BIM is able to collaborate and exchange information, and you're not relying on prompting someone to get information because you know how to access information from the central database. Then also, in construction sequence, BIM is more efficient because some activities can go on concurrently, unlike in the traditional method where you have to do first maybe your structural design, then after that the MEP person can start to work, then after the roofing person can start to work. But with BIM, you can collapse some of these activities because everybody can have data to be able to commence their work, and they can collaborate and save time. So it has high efficiency. Also, another important thing to mention is visualization and simulation. Like I mentioned earlier, you are able to, with BIM, simulate wind loads, earthquake load, lateral loads, internal comfort. You can simulate traffic, for example, pedestrian traffic in public places like train station. You can simulate with BIM and know what can happen at specific time. Also, you can do clash detection. Clash detection means you are able to analyze if there is a soft or hard clash, whether a structural element is going to be in the path of another element. So you can be able to resolve it before actual construction takes place. Also, you can also do clash detection for resources. For example, if one person is going to be requiring one resource and another part is going to be requiring the same resource, let's say, for example, crane, then you can, with your scheduling, you can know that, oh, there's a clash in the demand for this resource within this specific period, so you can address it. Then effectively you can estimate costs. Also, one of the things that is important to mention is that BIM uses this parametric design so that when you make a simple alteration on a model, the other section of the project can adjust in a parametric form in the design. It improves efficiency, it reduces waste, and helps to manage costs because the need for rework is reduced. Like I mentioned earlier, if you are able to identify where there will be clash detection, then the need for rework will be reduced. So it is a cost-saving technique, and it helps communication and collaboration. This is an illustration to just illustrate what simulation is all about. You can simulate comfort of the occupants in the building. You can simulate building load. You can visualize specific elements if there are going to be clashes. You can do your estimation. You can do your clash detection using BIM. These are some of the statistical figures showing the benefits that BIM offers lower emissions, lower costs, faster delivery, and reduce documentation errors, because everybody is working with the same version of documents. Unlike in the traditional method where you may not know which version of document is the current version. With BIM, there is only one version and everybody has the current and up-to-date information. So this reduces documentation errors. I would like to analyze some of the key terms that is consistent with BIM. One of it is the BIM protocol. What BIM protocol says is you define the process, the people, and the technology. You assign responsibility, you assign schedule, you assign resources using BIM. Also, you can know who is responsible for each model, who is the model author, and what information is required for that person to be able to carry out their work, and the outcome of their work, who is going to benefit from the outcome of their work. So that's what BIM protocol talks about. I've mentioned this earlier, the common data environment. Unlike in the traditional method, when you have to request for information, the client has to ask the contract manager for information, who may have to ask the AEC, the architect or the engineer for information, who may be requesting this information from their supplier. And there's a lot of back and forth, which takes a lot of time. And in the middle of that, some information can be lost or be misinterpreted. But with the common data environment in BIM, everybody have access to data, the required data for their own work, for their own portion of the work, and they can collaborate with others. Subcontractors can interact with the main contractors, having the same version of information that they require for whatever they need to do. So the main contractor can monitor and collaborate with the subcontractors. So the subcontractors will not be having to request for information on the project. So the number of RFIs will be reduced. I also mentioned IFC earlier, which is the collaboration format that states that the documents are saved in such a way that with whichever platform or whichever software any of the team members is using, everybody will be able to share this information without losing the integrity of the data. These are some of the acceptable format for data sharing, the acceptable extension for drawing, the acceptable extension for pictures, extension for text, extension for XML files. And with BIM, you can use the IFC extension to be able to share all these files, including your scheduling files, your text files, and any other information that relates to the project. Information requirements. Information requirements. Three things are important when we talk about information requirements. Who needs this information? What do they want to do with this information? For example, the subcontractors will need information as about, let's say, the MEP subcontractor will need information about the specification for pipings, for example, so they know where to get that information. So they don't need to request from the main contractor. They know whether they need to use the steel pipe, the stainless steel pipe, or they be using the PVC pipes, because that information is already available. Then when is the information required? And how, in what format is this information given? I mentioned in the previous slide the standard format for exchange and collaboration of data. Then who is going to be the receiver of this information? Also, I've explained the difference between high level and detailed level information. For example, the client will require high level information because they don't need to know the entire detail or the entire specification of an object. But the subcontractor needs to have specific dimensions, specific details about the object. So the high level information is for the client. The detailed information is for the subcontractor. Some of the things that I've also mentioned, the way to analyze key terms. The technical section will talk about, in your BIM execution plan, you talk about your software platform, you talk about your data exchange platform, you talk about your coordinates, your level of details, and the training requirements. For management, you will talk about your standards, your roles and responsibility, the planning of the work, segregation, coordination and class detection, collaboration process, HSC, compliance plan, scheduling. That is all under management. Under commercial, data drops talks about at what point is this work acceptable and has commercial value. Oh, this work is delivered and is acceptable because it has met the requirement. What is the client's strategic purpose? What does the client want to achieve? And what are the deliverables, sub-deliverables that will make this holistic purpose be achieved? Then what are the specific competencies that BIM is going to offer? Some of these I've mentioned or I'll mention again in the future. Organization information requirements. Organization information requirement is for anybody collaborating with the organization, what information is the organization requiring from them and what information are they requiring from the organization. Project information requirement is specific to a project. Assets information requirements talks about the details that relate to the built assets. The exit information requirements talks about at the point that you're passing information to the next person, what kind of information does the person require? When does the person require it? In what format does the person require it? Another thing that is important to mention is the role of the appointing party and the appointed party. The appointing party is the client. The appointed party is the contractor and the subcontractors. So the appointed party is going to provide a tender proposal, their method statement, their value proposal, their execution plan, their pricing. The appointing party is going to give an holistic view of what they want to achieve. Oh, this project is a rail project. This project is hotel project. This is a multi-dimensional housing estate or whatever it is. Then they are going to give some background information with budget. Oh, this is the budget we have in mind. This is how this finance is going to come. This project schedule, we expect this project to be completed by 4 years or in 3 years, they are going to provide the appointed party with this information. So this is going to serve as the constraints within which the appointed party will work. Then the appointed party can now give information as to, oh, we will be able to meet your requirements, we can work with this budget, we can work with this schedule, and so they'll submit that with a tender proposal. Another term that is important to mention is IDM. That's the Information Delivery Manual. This Information Delivery Manual is backed by the ISO 29481 version 1 2010. It talks about how a file has interoperability. I mentioned that before. Interoperability means that the file is saved with an extension that is not reliant on specific software vendors. That means if I work, for example, with Revit, if you use another software in your office, we can share data without us losing the integrity of data. Some of the other terms that are important in BIM is that there are standard models that we can pick, and it makes the work faster and easier because these models are standard and are cross-board. To critically analyze the advantage of BIM over traditional building methods, the bulk of the work in BIM is done at the initial and planning stage. The line graph for the efforts in BIM is shown in blue, indicating that the bulk of the efforts comes in the pre-design and the design phase, because the impact that has the maximum impact on the outcome of the project, and it will eliminate errors and rework. Unlike the traditional method where the bulk of the work is done in the construction or after the detailed design, and that is what leads to a lot of errors. And this red line shows the costs associated with a change in design or environment. If at the construction stage, a change is requested, the impact is usually huge. But at the design stage, the impact is minimal. Another aim BIM can have is it can help to save costs. It can help to reduce construction costs because most of the rework is eliminated. Request for information is reduced. Request for change is also reduced. And planning is easier because everybody is able to collaborate and work together. There's accelerated workflow because of the efficiency of planning and the collaborative tools that we have in BIM. To analyze it further, for the client is able to save himself money, is going to get the project faster, and it's also better for the environment. Then the risk is minimized because from the design stage and the conceptualizing stage, the client has an idea what the project is going to achieve, how the project is going to be delivered, at how much cost, and with what timeline. So that's the benefit to the client. To the construction manager, they're able to plan better. They're able to carry out their clash detection. Like I mentioned earlier, clash detection could be structural clash, or could be a clash in the demand for a resource. There's also reduced need for rework, and you can plan your work in such a way to say, oh, this item arrives at this time and in this quantity, so you can manage inventory better. The designers can collaborate because their work is visible to each other. They can see what the other person is doing and they can collaborate. The MEP is not waiting for the engineer is not waiting for the architect to finish before he can commence, and the MEP is not waiting for the engineer to finish before they can commence. The three of them can collaborate and work simultaneously. Then the operator or the owner, who may also be the owner, has asset knowledge. For example, the lift in the building, the operator knows the lifespan of the lift, the manufacturer of the lift, when the lift is due for maintenance, what parts, how to order the parts. All of this information will be provided in BIM. I cannot overemphasize collaboration in BIM, which is one of the key terms in BIM. Everybody is able to communicate, cooperate, brainstorm, share ideas, particularly in the planning stage. This has a big impact on BIM. The fact that everybody is able to share ideas together from the beginning, from the conceptualizing stage, everybody is going to be able to share ideas together. That is one major thing with BIM. Another important thing to mention is the common data environment. Everybody have access to information simultaneously, and this information is typically given in standard format that everybody can understand. One other important thing which I mentioned earlier is that you can use BIM to do simulation and visualization. This is a wind tunnel simulation done on Bojalara to determine the impact of wind load on the building. You can also carry out simulation to know what the pedestrian traffic can be at a public space, for example, airports, metro station, and the rest, so that you can avoid stampedes or overcrowding. Visualize what the structure is going to look like. This is the 3D model. This is the built drawing. You can see that it's comparable. I've mentioned this earlier, that BIM is involved in the entire life cycle of a built asset. It's a parametric modeling design method. You can use it to detect clash. You can coordinate with various design disciplines. You can do your construction planning, and you can do your asset management using BIM. Now, the dimension of BIM. One to the research and initial stage implementation and concept design. 2D talks about two-dimensional production, and 3D talks about the 3D model. 4D talks about estimation of time scheduling. That's the fourth dimension in BIM, where you can do your scheduling, when an activity will start, which activity is dependent, which activities can run concurrently, and which activity must complete before the others can take over. So you can do your sequencing in BIM. Earlier, you can also do clash detection for resources. You can, for example, if this crane, if, for example, if the MEP would require this crane at a particular point in the project, and someone else will require the use of the crane, you can reschedule one of the activities so that there's no double demand for the particular resource. The fifth dimension in BIM talks about cost elements, how much each unit is going to cost, and that can be, you can visualize the cost, and you can also see it in text format. The sixth dimension talks about the sustainability, how to reduce waste, how to improve energy efficiency, then how to manage the comfort of the occupants in the building. You can simulate the air, cooling and heating requirements in the building. Then in 7D, this is the operation. 7D talks about facility management or operation of the building. The facility management has access to information about every element in the building, and they can plan maintenance activities accordingly, and they know where to order, who to order what materials from, because the ninth dimension is about lean construction. Lean construction is about eliminating waste in construction. Which material is required, in what quantity is it required? And finally, the 10th dimension is the integration and collaboration among various stakeholders, where it is not just those that are related to the building activity or the construction activity that can interact with BIM. The 10th level of BIM is where policymakers, government, stakeholders, public can have interaction and input. One of the ways you can use BIM in a project is animation and visualization. You can actually see what the structure is going to look like, what the layout of the structure is going to be like. You can also do your clash detection. If a structural element is going to come into the path of another structural element, then you can detect in BIM, and you can define another path for either of these elements in the model stage before the construction takes place, and this helps to save money and rework. Also, BIM improves efficiency. It helps to evaluate design options because you can create multiple designs and you can choose whichever design you want to pick. For the facility manager, you're able to simulate what the environment is like in the inside of the building, which portion of the building will require cooling. Also, for the facility manager, is able to, by using sensors and monitors, they can be able to analyze what is going on within the building. This can be simulated during design, and this can also be measured in the operation stage. BIM execution plan. To create a BIM execution plan, you need to define what you are going to use BIM to achieve in that project. Who is going to be responsible for which part of the project, and what ways are they going to use? What process, what tools are they going to use? And what is the point where data is going to be exchanged? And what is the infrastructure that is going to support BIM? These are the key elements of the BIM execution plan. I've mentioned this earlier. In the design stage in BIM, the AE, or AE and C relates with the client or the owner or the sponsor, and they have background information to develop the concepts. During the construction, there's coordination, collaboration, class detection. In post-construction, you have information for the facility manager and the person that is going to operate the building. They will have information about assets. To create a BIM execution plan, you understand the project requirement, you define the roles and responsibility, you establish BIM standard, you develop BIM execution strategy, then you determine the level of development or the level of detail. Then you manage your BIM data. Then you establish your quality control procedure. These are the key things in developing BIM execution plan. LO3. The key differences between BIM and traditional construction method. As mentioned earlier, in the traditional approach to construction, there is no central repository for data, and there could be a lot of misinformation because each person is depending on one person for information, and the person may not have the current or accurate information. But with BIM, information is centralized and everybody has access to accurate data. Another thing that is possible in BIM is you can visualize the work and you can carry out your simulation. Also, one other thing that is important to mention is in your design, in traditional method, like I mentioned earlier, the architect will finish before the structural engineer would do, before the MEP can do, before the interior designer can design, before the design check. But using BIM, everybody can collaborate and they can work concurrently, and this gives time reduction. It's important to mention that in BIM, you're able to coordinate, communicate, and collaborate. Coordination means that the main contractor is able to understand the activities of the subcontractors. They are able to communicate with the subcontractors. They know what information the subcontractor needs and at what point they need that information. And every participant is able to collaborate. One of the ways that BIM can help in construction industry is clash detection. And we have what we call the hard clash, the soft clash, and like I mentioned earlier, you have the logistics or temporary clash, or sometimes you have what the workflow clash where there's a demand for a particular resource in a project. So with BIM, you can identify the problems early and you can solve them. Also, BIM gives you quality assurance because you have an idea of what is expected, you have the model. So everybody has an understanding and they can track what is going on. Also, you can visually represent what is going on site, unlike the traditional construction method where you go for project meetings and you are seeing only charts. In BIM, you can see graphical 3D modeling of what is expected as well as what is actually built till date. So BIM helps to create clear channel of communication. It helps to define the roles and responsibility. Then it gives a common platform for exchange of information. It gives flexibility and adaptability. Like I said, it uses the parametric design method. One of the ways that BIM can impact project outcome is that BIM can help to save time and cost and help to ensure that the objective of the project is met. Because from the beginning, from the initiation stage, everybody understands what the project is going to achieve. And during the design stage, you can save time because everybody is able to work concurrently. Also, in the construction stage, you are saving time because adequate planning has been done. Then the need for rework is reduced. This helps to manage costs because we do not have to do a lot of rework, or we are not waiting for information because we have access to information. So this is one of the ways BIM can impact the project outcome. I've already mentioned this. BIM can help to save costs that can occur due to change in design or change in requirements in the construction stage. By anticipating what can happen using simulation tools available in BIM, we can avoid a lot of costly mistakes that can happen during the construction. Also, because BIM has full life cycle information, it gives an advantage. It means that the building operator or the facility manager has information. Is not going to be searching for information about, for example, the lifts or the conveyance system or the heating and ventilation system, when they need to be maintained, how they need to be maintained, who can carry out the maintenance, because they have that information. So that's one of the key advantage of BIM. It gives the operator and the owner access to information about their assets. One of the other things that is important to mention, which I've discussed earlier, is these are the key benefits of BIM. Design can be done faster. Everybody working on the project can collaborate. You can reduce errors and rework. And it improves satisfaction because the client or the owner has an idea how much money and how much time is required to achieve the objective, and if the objective is actually realistic. Also, the owner of the building have access to information on operation and maintenance when they want to carry out renovation or when they want to carry out demolition. They have access to information as to how to dispose waste, how to recycle waste, and in what manner, in what form they can dispose the building at the end of the lifespan. Also, the owner of the building can manage the occupants' comfort by using sensors. They can manage space because they have an idea. They're using the visualization tools, they can manage space and they can achieve the sustainability objective. One other important point to mention is that BIM affords the opportunity to have up-to-date information and record keeping. You can carry out your preventive maintenance. You can have a disaster planning arrangement because you have done your simulation. In the event of a crowd, how do you divert the crowd? You can analyze your building energy efficiency. Oh, this building requires this amount of energy at this time. This is how to allocate these resources. This is the amount of power requirement. This is when to shut off power in specific places. And you can have information about the valuation of your assets. So if, for example, you want to use the asset for mortgage, you have accurate information or data as to the valuation, the lifespan of the property. For example, if the building is given a 30 years or a 50-year lifespan and you are 5 years into the building, you can estimate the current value of the assets. So that's one of the advantages to the owner of the property. There's improved efficiency, there's enhanced safety, and there's improved asset management tools in BIM. How information is managed, created, managed, and used in BIM. At the inception, the background information is captured while you are gathering information about the asset. Some design activity and analysis can begin. You can begin to design the concept. You can begin to analyze the building performance based on the concept while some of the information is being gathered. That is one of the advantages of using BIM because some of these activities can go on simultaneously. In the design stage, the model author can design, and the building performance is also being analyzed in the design stage. This also continues into the production stage. The model author can estimate from the design stage the value of the asset up to the demolition stage. This information is available. The analysis of the sustainability, this information is available from the design stage up until the end of the lifespan of the project. The information about the construction documents is available midway into when the design has started and into the construction stage. Then you have information about waste management throughout the lifespan of the project. In relation to how information is managed, As mentioned earlier, the appointing party provides background information as to its requirements. What are the environmental conditions? Environmental condition means site analysis, then what the project wants to achieve, what is the objective of the client, and if they have a preliminary design. A preliminary design could be, I want an iconic structure that is the tallest in the world, or I want an iconic structure that is green and efficient. So those preliminary information, the appointing party is going to give the appointed party, who is going to be the AEC or the consultant or the main contractor. So with this information, the appointed party is going to give the appointing party their method for achieving this objective, their proposed value or value engineering. If you are able to use this technology, you'll be able to achieve this. If you are able to use solar, or if you are able to make wind turbine, or if you are able to, for example, in cement, for example, they use a lot of passive design elements to achieve sustainability. They put water on the ground floor so that when wind comes into the building, it's going to blow on the surface of the water, helping the building to cool, reducing the requirement for mechanical ventilation. This is passive design. So the appointed party is going to say, oh, I'm going to put this much of passive design elements to help you to be able to achieve this objective of sustainability. So the appointed party is going to give the appointing party this information. So that is how information is managed using BIM. Also in BIM, there's collaboration. So information flows from the architect, also from the MEP, and the safety or the fire life and safety in Dubai is called fire life and safety elements. So all of this information is analyzed simultaneously using BIM software to be able to say, oh, if we alter the design slightly, this is going to be the impact of this alteration. These are the information exchange points or triggers in BIM. The triggers or the information exchange points refers to at what point information is required, by who is this information required, in what format is this information required, and for what purpose this information is going to serve. As I mentioned just now, the information container will specify, oh, I want a door. It's going to talk about the location of the door type, and the door specification. When, at what stage do we want this door to be delivered? This is where we can deliver the door. This is the earliest time that the door can be delivered. This is the latest time that the door should be delivered without causing a delay. Then who is responsible? Who is going to carry out that activity? Within your BIM execution plan, you are going to define what, when, and who. The rules that are required in a BIM-enabled project depends on the complexity in a project. You could have a project that will have BIM manager, BIM coordinator, BIM specialist, BIM model author, BIM technician. And you could have a project that will require only a BIM coordinator that will see to the day-to-day interaction or collaboration among all the stakeholders. Some of the defined roles or the people that have impact on BIM is the project manager. In the design stage, the project manager would create a schedule and a budget for the project. And during the project, in the design stage, it can track the design. In construction, it can track the project because they can measure what is done in comparison to what is expected to be done. The BIM manager, the BIM coordinator in the pre-design stage can gather information about the project goal, objective, and constraints. The architect has information about the conceptual models of the building. The owner initiates the project and defines the project goals. These are the key people that are required to execute a BIM project. The BIM manager, the owner or the client or the sponsor, the project manager or the contractor. Also, you have the architects, engineers, and designers, the BIM modelers or technicians. Then you have the operator or manager, who may also be the owner of the project. Depending on the level of complexity in the project, you may also require BIM specialists or BIM consultants, BIM software developers. The important thing to note is that the complexity of the project will determine the specific roles and responsibility assigned to each of these participants or stakeholders in a BIM project. In the design stage in BIM, BIM is used to generate the 3D model. It is used to visualize the design. It's also used to identify potential conflicts in the design stage. And this is one of the major advantages of using BIM because you are able to identify conflicts or clashes, and you are able to visualize the design. This is one of the major advantages BIM have over traditional construction method, because this helps to save money and time. You can also use BIM to improve the sustainability of the building using the simulation tools that are available in BIM. In the construction stage, you can use BIM to track the progress of work. You can visually track the progress of work, whether the work is on track or not, and what needs to be done to put it on track. In the maintenance, operation and maintenance stage, you can use it to track the building's condition and also to plan maintenance activity. In the demolition stage, you can use BIM to know the right technique, because you know which are the required load points or failure points, that if you're able to cause the building to fail at this point, then the building is going to collapse. Then also how to dispose the waste resulting from the demolition, because you have access to information. So BIM is useful in the design, construction, operation, and the demolition of a built asset. One of the ways information is shared is using the standard tools, which I've already mentioned earlier. This BIM collaboration format is the future of BIM, where everyone, or level 3, where everyone will be able to use this format to exchange data, irrespective of the application they are using. One of the ways information can be shared is that the client can visualize the design and understand costs and make informed decisions. This is one of the value to the client because he has access to this information. The AEC, that's the architect, engineers, and the consultants, they can use BIM to collaborate with each other. The contractors can use BIM to coordinate the work of the subcontractors. And the owners can use BIM to manage the operation and maintenance of the building. The key people that are important in a BIM project is the BIM manager, because the BIM manager is going to define the BIM execution plan. And the BIM execution plan has the project information, the key project contacts, the project goal, the organizational role and staffing requirements, the BIM process design, information exchange points, BIM and facility data requirements, the collaboration procedure. Collaboration procedure is what information, who is giving what information at what point, the quality requirements. What is the acceptable standard for this project? What infrastructure is going to support BIM? Am I going to use cloud for this project, or am I going to use an on-site application to manage? So that function is carried out by the BIM manager. The design manager works with the BIM manager based on the BIM project execution plan to create a design, and the surveyor is able to use the information from the design manager to be able to do the layout for the project. The project coordinator typically works hand in hand for the day-to-day function of operating BIM on a project. With BIM, the BIM specialist, for example, you can have a BIM specialist that is for model coordination. You can have a BIM specialist just to check standard if the project requires that complexity. Some of these roles and responsibility are detailed further in this figure. Finally, conclusion. The future is yet to come in BIM. The future is about digital twin. Digital twin is much more than BIM, but it's similar to BIM because some of the features in BIM are also present in digital twin. The digital twin is giving virtual access to the built assets, So there's AI components in BIM added to BIM. That is what the digital twin. You can interact using the virtual reality tools or the augmented reality tools with the building. For example, with your AR tool, you can actually walk around the building and see a simulation of what the building is going to look like. So it's not just visualizing, you are able to interact, and that is the future that BIM has, or the future after BIM. So you can do analytics, you can add additional information. That is what digital twin is about. Also, the future for BIM is what we call the generative design, where you can create multiple, using AI tools to create multiple design options, and then you can import them to BIM to carry out your analysis. So the computer is able to generate a limited number of options for a particular concept, and you can be able to simulate and pick based on the constraints of the project, which is the best suited design. And that's the future for BIM, the generative design and the digital twin. Thank you so much for your time.
Thank you.
Yes.
So should I ask the question?
Please.
Since you are going for the distinction, let me put some points clearly.
Yes.
So you are familiar, since you have discussed so many practical examples of UA construction.
Yes.
Could you give me what is the main problem that Burj Khalifa has faced in its stage?
Two problems. One was at the foundation stage, and they did not anticipate the watering problem and the soil nature. The other thing is, in the cost of the project, they did not anticipate the budget for the project because they did not use BIM. So at some point in the project, they had finance problem, and they had to use they had to source for alternative source of funding. But if BIM was used for that project, they would have been able to analyze the data about the soil and be able to know what remedial activity they needed to do before commencing the project. Also, they will be able to estimate more realistically the budget requirement for that kind of iconic structure. However, I must say it was a huge success for them to be able to achieve that height.
So what another funded person?
Huh?
Party?
Was the
Second funded party?
that's Sheikh Khalifa, and so that altered the name of the project. The project was conceived as Burj Dubai, but the new owner or the new investor altered the name of the project.
Okay. Can you give me example of the structure one name which has adopted the BIM technology in UAE?
A number of them have adopted BIM. One of them is the Siemens building in Mazda City. They use BIM, like I mentioned earlier. They use BIM to do a lot of simulation, and that is why they were able to use a lot of passive designs to be able to achieve sustainability. It has maximum light illumination without having sun ray coming into the building. They have illumination without allowing sun ray because they have used these aluminum fins. Also, they use, like I mentioned earlier, they use water on the ground floor in the pathway of the wind direction because they use BIM to analyze the predominant wind direction. So they adopted BIM, and was an excellent project.
Okay. Can you give me two-line definition on parametric design?
Parametric design, unlike the metric design, which is the traditional design, means that when you make little adjustments on an element, the other part stretches or conforms. I can illustrate if I can draw with this. For example, if you have two ellipses and two circles joined by this conveyor, if you alter the diameter of this and maybe you make it this bigger, this element is going to automatically adjust itself to suit this constraint. So that is what one simple way I can define or explain parametric design. Generative design means that I'm not going to manually alter any of these elements. The computer is able to create several options for me to be able to pick the best suited.
And we have been adopting the BIM up to only level 2. Why not level 3?
Level 3 is when all stakeholders, including government and policy makers, regulators, are going to be able to make impact.
You mean to say ISO code?
Yes.
With respect to every nationality?
Yes, the 19650 standard.
Which is now BIM calling which ISO, I mean which nationality in ISO the BIM is calling now?
19650 part 1. The what?
Nationality.
National UK. Yes. Everybody is following the UK standard. That's why I said in the beginning everybody is following UK, but we expect that globally everybody will be able to collaborate and have the global standard for BIM. That will be the level 3.
I have a few questions. First of all, very good presentation, excellent presentation, and it shows the effort, the amount of work that you have put in this. Okay, I have 1, 2, 3, 4 questions. First one, you mentioned about lean construction, right?
Yes.
So what is it?
Lean construction is a modern, not so modern, about a decade old, introduced into construction to eliminate waste and to reduce rework or material usage. So one of the things they do in lean construction is what the concept of arrive when needed, when materials are arriving on site when needed. So there is reduced storage cost or inventory cost. Also, materials are planned in such a way that only what is required. So lean construction also uses modern building techniques where the models or the parts or the structural elements are constructed off-site and imported to site so that work can be done simultaneously and waste is eliminated and there is efficiency. For example, if one person is building only BIM and the person is doing it offsite, the person will develop efficiency. And it is not going to interfere with whatever construction is going on. So those are the elements. Lean construction is about sustainability and saving costs.
Reducing the waste.
Reducing waste.
Okay. Do you know about value engineering?
Yes, I mentioned value engineering. Well, a little bit. The idea of value engineering is to ensure that in the lifespan of the building, the building is designed to have the best lifespan and the best value.
Okay. Okay. Value engineering,
yes,
same as that of lean construction. Okay. But the difference is that the materials should be minimum with great value, even during the demolition stage. Okay, the materials can be reusable and that value of the material will not vary. So that is known as value engineering. Now, next question. So that was my first one. Okay. Are we using BIM here?
In Dubai.
Revit they are submitting. In Dubai.
In Dubai, BIM implementation, according to the Article 207, it says that BIM is required for 40 floors and above, or for project that is more than 200,000 square feet.
Okay.
That's
for complex projects.
Yes, for complex projects, or for projects that have stakeholders that are outside of the country. So those are the 3 requirements.
You mentioned about digital twin. The slide was excellent. The last one, the picture. So, are we using digital twin?
UAE is planning to implement digital in Dubai. They want to have a model of Dubai so that you'll be able to visit Dubai without coming to Dubai.
Now, okay. The third question. What is the lifespan of buildings in UAE?
For iconic structures, 50 years.
The normal buildings?
I'm not sure.
Iconic structures only 50 years or 100 years?
I've seen for some, I've seen 50 years, strange, but I've seen 50 years for
Okay.
some.
Okay, we'll come to that. How can BIM be helpful after construction?
After construction, in the operation of the building, BIM gives us information about specific elements for the operation and the maintenance of this. We can use BIM to plan maintenance requirements and schedule maintenance requirements in such a way that it does not affect the user of the building. Also, we can use BIM to plan the comfort or the suitability of the environment for the occupants of the building. Also, as mentioned, BIM is useful for demolition so that we can plan demolition and know how to dispose the output of the demolition exercise.
Thank you.
Thank you.
Presentation was very good.
Thank you, ma'am. How do I leave?